Okay, now solving the equation dp dt equals kp with the condition p of 2 equals 800, p of 6 equals $1,100. We get two equations that we can solve for k and a. We divided the two equations and obtained our solution for k. 1/4 natural log of 1.375. That comes out pretty close to 0.08. We'll worry about that later. We don't really need that to determine this. Now we have AE to the 2 times 1/4 natural log, etc. equals $800 just by substituting this value of k into this equation. We can simplify that slightly and we get AE to the 1/2 natural log of 1.375 equals $800. By the laws of exponents, this is equal to a e to the natural log of 1.375 raised to the 1/2 power. Now, the natural log, e to the natural log of 1.375 is 1.375. So, a times 1.375 raised to the 1/2 has to equal $800, so that a equals $800 divided by 1.375 to the 1/2, which can be written the square root of 1.375. Now, square root of 1.375 is about 1.17, I believe. And that's going to end up being approximately, well, let's not even approximate it. Okay, yeah, let's approximate it. 0.17 is about 1/6, so this will be about 6/7 of $800, which is going to be a little more than $800 less, so it's going to be about $686, big question mark there. You can figure that out with your calculator. I'm not going to get into that. So we've determined that A is about, if my approximation is correct, and I kind of doubt it, around $680 or something like that. And K is 1/4 the natural log of 1.375. And that's about 0.08. This tells us that our solution function, P of t, equals a e to the kt is about equal to, let's just say $680 times e to the 0.08 t. Now again, you can check my figures, and we can also check this solution by plugging in t equals 2 to see if we get about $800, and t equals 6 and see if we get about $1,100. And if you get an accurate solution, use your calculator to do these calculations, it would come full circle. Let's look at the geometry of this equation. If dp dt equals kp, well, we just determined that k is 0.08 for the given conditions here, so that dp dt is equal to something close to 0.08 times p. Now, if that's the equation, let's map things out on the coordinate plane here. We put p versus t, and we divide the p-axis up at 12 and 8 and 4, and 1 will be way down here. If dp dt is 0.08 p, then when p equals 4, this tells us that dp dt equals 0.32. Now that would imply that our graph has a slope, because the slope, of course, is equal to the dp dt, a slope of 0.32 everywhere where p equals 4. We've drawn a dotted line where p equals 4, and we're going to draw a bunch of slope segments of slope that I think might approximate 0.32. Might be a little steep, but we can live with that. And p equals 8 implies dp dt equals 0.64. So the slope is a little greater here. And when p equals 12, it's going to turn out that the slope is, well, 12 times 0.08 is 0.96, a slope pretty close to 1. So the graph, again, continues to get steeper. Now, these lines show us how our solution curves are going to behave geometrically. If we start out with a principal of, let's say, $686, well, $686 is way down here. We haven't even drawn the slope field here because the slopes get pretty small. T equals 1. Our slopes are 0.08. That's a pretty small slope. And if we're down here at $686, the slope is even smaller, but that means that we follow this curve and we continue to follow the trend of this curve. And I'm not doing a real good job of that, but you get the idea. And we get our principal function, p of t. Now, is that function equal to $680 times e to the 0.08t? I wasn't all that careful. I didn't do all that good of a job here. Just notice that this video is going pretty long. I think I made a mistake there, but we'll live with it. Okay. Now, is that consistent with the idea that P of 6 is $1,100? Well, 6 occurs here. That would be here in the function. It looks closer to $2,000 than $1,100, so I probably exaggerated the slope, but we get the idea.